We tend to think the ground we're standing on is, well, solid, rock solid, right? But what if I told you that the entire surface of our planet is actually moving? Constantly. It's in this super slow motion dance, all driven by these incredible forces from deep inside the Earth. So today, we are diving headfirst into the amazing science of plate tectonics.
And that's really the big question, isn't it? I mean, how can whole continents just drift apart? Why do we see these massive earthquakes and volcanoes in some spots but not others? Well, the answer is that the Earth's surface isn't one solid piece at all. It's actually a giant, cracked puzzle.
And if you want to see where this puzzle is most active, look no further than the Ring of Fire. Now, it's not a literal ring of fire, but it's this huge, horseshoe-shaped area that wraps all the way around the Pacific Ocean. It is, without a doubt, the most geologically intense place on the planet. And because of that, it's home to most of the world's volcanoes and earthquakes. Get this, 90%. That's how many of the world's earthquakes happen right here, in this one zone. And that is absolutely not a coincidence. It's a direct clue to the immense power churning away just beneath our feet.
So what is this incredible engine that's driving all this activity? To figure that out, we've got to look at the one theory that completely changed how we see our world.
And here it is, the big idea, plate tectonics. The theory says that Earth's tough outer shell, scientists call it the lithosphere, isn't solid. It's broken up into these massive pieces, or plates. And here's the kicker. These plates are not just sitting there. They are constantly moving, gliding, bumping, and scraping against each other.
You want to know the easiest way to picture this? Think of a hard-boiled egg, seriously. That thin, cracked shell, that's the Earth's crust, the part we live on. The mushy egg white inside is the mantle, and the yolk, right in the center, that's the core. Our tectonic plates are basically the big, cracked pieces of that egg shell.
So, what's making these shell pieces move around? It's a process called convection. Imagine a pot of water boiling on the stove. The hot water at the bottom rises, cools off at the top, and then sinks back down. Well, the exact same thing is happening inside the Earth's mantle. Molten rock gets heated by the core, it rises, it cools, and it sinks, creating these giant, slow-moving currents that act like a massive conveyor belt, dragging the plates on the surface along for the ride.
Okay, so if the plates are always moving, what happens when they actually, meet? That's where all the action is. We're talking earthquakes, volcanoes, the works. These meeting points are called plate boundaries, and they basically come in three main flavors.
First up, you've got divergent boundaries. This is where plates are literally pulling apart from each other. So as two plates move away from each other, this gap opens up. And what fills it? Magma from the mantle wells up, cools down, and hardens, creating brand new crust. This is literally where new Earth is born. Deep in the ocean, this forms huge underwater mountain ranges called mid-ocean ridges. And on land, it can create these massive valleys that are slowly, over millions of years, tearing continents apart.
All right, next up, we have the total opposite, convergent boundaries. This is where plates are on a collision course.
Now, this is where things get really dramatic. When a heavy, dense oceanic plate smashes into a lighter continental plate, the heavier one loses. It gets forced to dive underneath in a process called subduction. As that plate sinks deeper, it melts, and that molten rock forces its way up to the surface, creating explosive volcanoes. This kind of collision is responsible for some of the most powerful earthquakes and tsunamis on Earth, just like the ones that formed the Andes Mountains in South America.
But what happens if two continental plates crash into each other? They're both pretty light, so neither one really wants to sink. So just like two cars in a head-on collision, the crust has nowhere to go but up. The rock buckles and folds and just gets shoved skyward, creating these absolutely massive mountain ranges. This is exactly how the Himalayas, the tallest mountains in the world, were born. And our third and final type is the transform boundary. This is where plates just grind past each other sideways.
So here, the plates are just sliding past one another horizontally. But this movement is anything but smooth. It's like trying to slide two pieces of sandpaper against each other. They snag, they catch, and they build up an incredible amount of stress. And when that stress finally lets go, bam, it's released in a sudden, violent jolt that we feel as an earthquake. California's famous San Andreas Fault is a perfect example of this. You can just feel the tension building.
So we've got all this amazing geology, but what does it have to do with us?
This is where it gets really interesting. Why on earth would people choose to live in these incredibly active and, let's be honest, dangerous places?
Well, it all comes down to this classic trade-off, risk versus reward. The risks, they're huge. We're talking devastating earthquakes, tsunamis, violent volcanic eruptions. But for thousands of years, people have been drawn to these exact same spots. Why? Because the rewards are just as big. Volcanic ash creates some of the most fertile soil in the world for farming. And those same geological forces also push valuable minerals and resources closer to the surface. And this constant dance between risk and reward is the absolute heart of human-environment interaction. We can't stop the plates from moving, so we have to get smart. We have to adapt. We engineer buildings with special codes so they can sway and bend during an earthquake. We build incredible early warning systems to detect tsunamis racing across the ocean. We use satellites to monitor volcanoes, trying to get a heads up before they blow. We can't stop the Earth, so we've learned to live with it, to be smarter and more prepared for life on our restless planet. So, as we wrap this up, I want to leave you with a question to chew on. Now that you've seen how these plates pull apart, smash together, and slide past each other, which type of boundary do you think is the most dangerous for people? Is it the sudden, shocking violence of a transform fault, or is it the landscape-altering power of a convergent zone with its volcanoes and tsunamis? The answer isn't so simple, and it really shows just how connected we are to these deep, powerful forces shaping our world every single day.